Let's have a look. Physics, materials, specific heat capacity. Okay. Right, can you see that? Kind of bright this morning. Let's turn off the light. Okay. You have it there as well. So, a physics teacher is making an Irish coffee. He has 50 grams of whiskey, 100 grams of espresso, and I should spell espresso is E-X-S, isn't it? Or E-S? E-S, I think. Doesn't matter. Yes. Come in. Have you got Amanda with you?
Yes.
Hot chocolate? Hot chocolate?
Americano.
Americano?
I need you to be brave.
Yes. Americano?
Hot chocolate.
Hot chocolate and yogurt?
Yes.
Wow.
Happy.
Life is difficult, I know. Did you try your homework?
Yes.
Oh, good.
Is it homework? Oh, no.
Of course, physics homework. Did you do it?
Yes.
Ah.
But why?
They didn't.
Oh. Heaven.
All right.
Monitor.
What?
Monitor.
Monitor? All right. Now, so a physics teacher is making an Irish coffee. He has 50 grams of whiskey, 100 grams of espresso, and
Coffee has whiskey.
it does. True. And you should try it. It's nice.
Where?
If you go to the pub at the corner.
Temple Bar.
No, the nearest place is at the pub down there.
What is it called?
Pub? Oh my goodness, you know pub. Where you go to drink?
The one at the junction.
The one at the junction, yeah.
Name?
What's it called? Leonard's Corner.
I know.
Yeah. They make a very nice Irish coffee there. Very nice. You should try it. You're old enough, yeah?
Yeah.
Yeah, okay, fine.
So it's everything with Irish and the front means that whiskey in it. It's like Irish cake, there's like whiskey in the cake or something.
Usually, yes.
Yeah.
Yes. You are yes or no for alcohol?
Yes.
You are yes, okay.
I'm on neutral ground.
Neutral ground, fair enough, okay.
What do you mean by yes or no?
I mean, we'll have no problem taking it or not.
No, Indians in my country, they drink the most. My religion.
Is it really? Okay. Anyway, whiskey. So, how long would it take to heat the water from 10 to 100 by using a 2 kilowatt kettle? Okay. So let's try that one first. Part A. Whoa. Whoops. Okay. First we should get the energy. Right, what's the mass of the water?
0.3.
0.3. And then the heat capacity is, what's it, 4181. And the temperature changes 90. So, that comes out as 112,887 joules. Power is work over time. Time is work over power. 112,887 over 2000. 56.4 seconds. Yeah. Bread as well. No. Alright. Next. Yeah. So B. How long would it take to heat the espresso from 10 to 80 by using a 3 kilowatt coffee maker? Okay. So it's the same thing. And what's the mass? 0.3. 50, isn't it?
What? No, wait,
Zero point
wait.
No, sir, no. 0.05. The capacity, I think I said take it the same as water, didn't I?
You didn't say it in the question, but you said it in the question before.
Okay. And then the temperature change is 70?
0.1.
0.1?
So whiskey, alcohol.
Yeah, but I wanted the coffee.
70 degrees.
So it is 0.1.
Oh, it's 100, thank you.
So it's 0.1.
0.1.
Yeah.
That's better. Right, 4181 and the temperature is 70. Yes? Right.
Yes.
Yes.
Time is 9
What? I don't understand this language.
The time.
The time, let's see. So power is work over time. Time is work over power. 29267 over 3000. Quite short. 9.78 seconds. But you kind of know this because when you see them making the coffee in the machine, it doesn't take too long for the,
Which machine?
you know, when they make the coffee and they put the coffee in and then they close it and they put the little cup and yeah, this thing. When they hand make it,
Which one?
like in Starbucks, you know, they have the little scoop and they put the coffee in and then they put it in the machine, and that part too, yeah. Alright, next. The cold whiskey is at 20, is added to the hot espresso. That should be X. What is the final temperature? Okay, so you have the whiskey and, well, I said it's cold, but that's actually quite warm. Mixed with the espresso from the last part. Okay. So what you do, here is the coffee. What's the temperature of the coffee?
80.
80, is it? And then the mass is 0.1 kilograms. And then you mix in the whiskey, which is 0.05, and its temperature is 20. So when they're mixed together, this becomes X and this becomes X. And X will be bigger than 20, but smaller than 80. Make sense?
Yes.
Yeah. So the energy, which is, let's see, which is the hotter, this will gain and this will lose. The energy lost from the coffee will equal the energy gained from the whiskey. So we have M C delta T, which will be 80 minus X equals M. What's it for alcohol? 2300. Alcohol, and then this one here will be X minus 20.
Can I close the window?
Yes, that's fine. Yes, you're not strong.
Yes.
Okay, got this? Did you get the same equation?
Yes.
Can I trust you to give me the answer?
55.4.
That sounds believable.
Yes.
55.4 Celsius.
58.4.
58.4. What did you get, Amanda?
60.
Oh, why can't you get the same answer? Alright. Let's check it.
You can use the 100.
Yes, I'll cheat. Okay, so anyways, while we're checking that answer, let's have a look at the next part. The mixture now has the hot water added to it. What is the final temperature of this mixture? Okay. So I need I need this part before I can do the next part.
I don't know.
So what happens in the last part is you have your hot water. You have your, no, that's not right. You have your coffee, isn't it? And then you have your whiskey. And then you have your water now on top. Yeah. This is 0.1 kilograms, 0.05, and what's it for the water? 0.3 kilograms. And the temperature, we need to calculate the temperature here. They're all the same, whatever this is. Okay. Right. I'll cheat, because I'm a cheater. 0.1 times 4181 times 80 minus x equals 0.05 times 2300 times x minus 20. And the answer is 67. Great. That's okay. 67.1. Yeah? Yes, it will be helpful. Right, so now you mix these together and let's call their temperature at the end Y. Now, sorry, actually, maybe to be a bit clearer, this 67, this isn't for all of them actually. Which one's 67? The coffee and the whiskey. That's 67.1. But then when you mix them together, they become, we'll say, Y. How hot is the water? 100, is it? 90, okay, 90. Alright, so the water, does it get hotter or colder? Colder. And the whiskey, hotter or colder? Hotter. And the coffee? Hotter. Oh, you can't see that, sorry. This gets colder, this gets hotter, this gets hotter. Do you understand why? Yeah. So, the energy that the whiskey and the coffee, the energy of the whiskey plus the energy of the coffee, that will equal the energy lost by the water. Make sense? Coffee. Yeah. Yeah? Okay, so M for whiskey. C, what's the C for whiskey? 2300?
233.
Yes. And the temperature will be Y minus 67.1 equals, plus, now for the coffee, 0.1, 4181, and then it's going to be the same, Y minus 67.1, I'm running out of space, equals, now for the water, MC, but this one will be Y minus 90. Got it. Let me put that up to the top.
You can
Zoom out.
zoom out.
Yeah.
More space.
Yeah, thank you. Okay, can you see it though still? No, it's too high. Yeah.
Also, three of them mixed together, so the higher one equal another one.
I don't understand.
Yeah, maybe.
No, it's not. 90 minus y. Thank you. That's too early. Are you in a hot dog?
No. Oh, yeah. I finished one.
Okay. Right, now, I'm going to be lazy because I'm tired and get the program to solve it. So,
If there are four things add together, if the lower temperature add together equals the higher temperature.
the lost energy equals the gained energy. Yeah. What's happening? Okay. 0.05 times 2300 times y minus 67.1 plus 0.1 times 4181 times y minus 67.1 equals 0.3 times 4181 times 90 minus y. Solve expression, solve, simplify, approximate. 83 Celsius is what I got. 83.2. Yeah? You did it this way?
No, I don't know how to do it.
Now you know? Okay. Next, let's see, that was D. The Irish coffee is placed on the window of the kitchen, which is 100 meters above the ground. The Irish coffee is knocked out of the window. How much hotter would it be when it hits the ground? So, what happens here? Here's the drink. And then it falls. And what happens is the potential energy here, when it hits the ground, becomes heat energy.
Is this the coffee or the something in the ground?
The drink hits the ground. Yeah. So let's get the potential energy. This is now D. So potential energy, mgh, and the m is 0.05. Huh? Is it? It is, thank you. E. 0.05 plus 0.1 plus 0.3 g h. Okay. 0.05 plus 0.1 plus 0.3, so this should be that. It is times 981. Right, so that's 441 joules. But actually, yes, 441 joules. Is that part okay? So the energy the whiskey gets, plus whiskey, plus the energy of the coffee, plus the energy of the water, that should equal 441. Okay, the whiskey is 0.05, and the alcohol in it is 2300, and we'll call the new temperature Z. So that would be Z minus 83.2 plus 0.1 times 4181 times Z minus 83.2 plus 0.3 times 4181 times, can you still see? Z minus 83.2 equals 441. Yeah?
Z.
Yeah. No, we're in Ireland. You can say Z. In America, they say Z. Yeah. So Z, yes.
That is 441.
Z?
Yeah.
441? No, Z is the temperature at the end. Yeah. Okay. Yes.
Delta Q is what?
The heat energy in joules.
Total?
Yeah, the extra from the potential energy. Potential energy becomes heat. Huh? Yeah, 441. That's the potential energy. Right, so let me see. Now what's nice about this equation, if you notice, is that this is the same. Oh, you can't see that, that's too. This is the same in all of them. So we can go. So you can put this together as 1787.4 times Z minus 83.2 equals 441. And you get, it's only a little warmer, 83.4. Is that okay?
So just change 2.2.
Yep. Well, it's not. I mean, if I drop your drink out the window and it hits the ground, it's not going to be that much warmer, but it will be warmer.
Become 40 and 83.4.
Instead of 83.2, yes. Yes. So if your coffee gets cold, you just drop it out the window, go downstairs and pick it up. Okay?
Wow.
Right. Now this is actually, this one here was noticed when you have a waterfall. You know waterfall?
A place name.
There is also a place name called Waterfall. But do you know this?
Yeah.
Yeah. So the water at the top and the water at the bottom, they're different temperatures. You got that okay?
Yeah.
Don't make a mess. Please don't make a mess. You will be clean? Okay. There is a small difference in the temperature at the top than at the bottom. Which will be hotter? The bottom, yeah. Because the water has potential energy here and kinetic energy, but down here it has only kinetic energy. So the potential energy was converted into heat energy.
The yogurt
Yes.
in here,
Yes.
why the taste is sour?
Ah, no, sour yogurt's delicious. And then you can mix some fruit with it to cancel the sour.
But original taste is not anything taste. Why is sour?
Yogurt normally tastes sour. This is the natural taste of yogurt. True. And then you have to add sugar or fruit. No.
Nothing can.
Yeah.
You don't have sour yogurt in China?
Original taste is sweet.
Yeah.
Original. Original where?
I don't know.
Original Chinese yogurt? Not interested, thank you. I'll take original Irish yogurt.
But my dad used to make yogurt. And
Really?
Yeah, and tastes very, very sour.
Yes. No, sounds good.
No, it's too sour.
But then you can put lots of honey or fruit in
that's
it.
what my mother do.
Yeah, good, yeah. And then you can have your Coke with it, you know, put sugar in your coffee. Yes, it's all good. Okay, last question. It's a cold night and the temperature of the ground is 1 Celsius. The coffee will give heat to the ground until the equilibrium is reached. How much energy? So what's going to happen now for the last part? Here's your cup of coffee on the ground. Its temperature is 83.4, but this is only 1 Celsius. So what will happen to this coffee? What temperature will it become overnight? Will it stay at 83.4? No. Will it become colder than 1? No. It will become 1. This will reach the same temperature. Remember, this is called, well, it's not called the first, it's called for the second law. That the heat here will go into the ground because the ground is colder. So my question is, how much heat? So delta Q equals M, what's the first one? M C 82.4, and then the next one is 0.1 times 4181 times 82.4 plus 0.3 4181 82.4. Okay. So I get 14782 joules.
You just find
Yeah.
the temperature by 1.
Yeah. 147 kilojoules will be lost to the ground. I made this problem a little bit simpler because real Irish coffee also has cream on top.
Okay.
What's cream? Oh my goodness. Cream.
What's the
Yeah. Lots of cream on top. Lots. Delicious.
like cappuccino?
No better. Really thick, heavy, delicious cream. Delicious. Okay, finish that one now? Yeah. So, in the exam, these types of questions, this would be like a section B question, because it has multiple parts. And you get this in the exam sometimes, in section B, where you would have like hot water and cold water, and then they mix it together, and they want the temperature. But sometimes they mix 3 things together. But I want you to see that just because there are 3 things, it just makes it a little bit bigger to do, but it's the same idea. If it's 3 things or if it's 2 things. Yeah. Alright, next lesson, so be strong.